So let's have a look at these transformations. We won't bother with write down the coordinates. Well, actually, do you know how to do coordinates? Define yet?
Yeah.
What are the coordinates of A then?
4, 5, or 5.
So 4, 5, yeah. And the coordinates of B? 2, negative 1. Good. Okay. Coordinates of 5. Mark with a cross point D so that ABC is a rectangle. Okay, actually, that's quite important. How do you decide? Because I remember we had a question like this, and a lot of you struggled with how to make it a rectangle. How do you decide where it's got to be?
How did that estimate? I just count the squares 1, 2, 3.
Okay. Well, estimation is a bit that you'd like to get it wrong. Counting squares is better. I think we had a method before was with a rectangle, it's got to be right angles, yeah? So if I'm looking at, well, there's that one and there's that one. Well, we've got to kind of have the same thing. So I look at it and go, well, from B to C, it's down 1 across 3. So from A to D, it's going to be the same. So I would go down 1 across 3. And that's where it's going to have to be. And then I would go B to A. I would go, it's across 2, up 6. So from C to D is across 2, up 6. Okay. Does that make sense? So you can work it out that way. One thing, your point has to be on the cross of the grid. Okay? Just make a note to yourself. Use the grid. Okay? Definitely use the grid. Don't have D here somewhere. Alright? It will be definitely on the point of the grid. Okay. So I'm going to come back to some of that in a sec, because what I want to actually do is get on with some of the transformations and stuff. Okay. Okay, so we've got lines of symmetry, which basically means we're going to reflect on this question. Right. Now I gave you this red thing, okay? Because what you do with this red thing is it's like a mirror, only it's also see-through. So it's going to be easier to see where it's going to be. So if you have your red thing, like if I want to reflect it in each of the lines, what I do is this. So you do it on the table, but if you put your red thing on the line, that's the line of reflection. So if we're going to do a reflection, that's the mirror line, and then you look in, you should be able to see the reflection, but still see the grid that you've got behind it. Okay? So you can kind of see and you can draw in the points. Does that make sense? Okay. Which I think these are really useful. They're more useful than the mirrors, because the mirrors you can see the reflection, but you can't see the grid the other side. So with these you can put it down, put your pencil behind it and still see it. So I presume you're going to be allowed this in your exam, so check, make sure you're allowed. Okay, so look at this reflection. Another way to do it, if you're not needing your mirror, is to look at, if you've got the mirror line, find a point. So we've got a point here, that point's on the mirror line, so it stays there. Alright? I'm going to look at this point here. Now this point, we look at it and it's 4 away from the mirror line, so we have to go 4 the other side as well. So we're matching the distance. Okay? And this point here is on this mirror line, but it's 4 up, so I'm going to go 4 up. So my reflection in this line is like that. and then I do the same the other side. So again, this point on the mirror line, if I'm going in this direction now, this point is 3 away, so I've got to go 3 away. This point here is 1 away. So there's my next one. And then I can probably finish it off. Okay. So that's just a simple, we've done a reflection there, but we've done it in terms of lines of symmetry. Okay. Now what I would say, my tip is be accurate, be careful. You don't want to kind of go one square out. If it looks a bit odd, you've probably done something wrong, so it's worth checking. Okay, so we're still talking transformations and things, but in a slight, it's not reflection in terms of lines of symmetry now, because we've got two separate shapes, but we've got to find, it says describe fully, so it says describe fully, that's very important there. The single transformation, okay, therefore if you do it in 2 steps, you'll lose all your marks. So single transformation that maps P onto shape Q. Now what does it look like? First thing to you, it looks like, well the thing is, if I picked that up and moved it, would it look exactly like that? No. So we're ruling out translation, because if it was a translation it would just be moved, right? This one, however, it could be a reflection. Could it be a rotation as well?
Yeah.
Maybe could be a rotation as well. But I'll tell you what, let's go for both options. Let's see. Okay, yeah. So this is the thing. Once you've decided it's a reflection, you've got 2 ways. You can use your red thing, your mirror, put it down the middle and find the right line. Another option is to go, well, I picked the points like when I drew it. If I pick that point and pick that point, which will be reflected, how many squares are between? 4. So if I go halfway, and then I pick 2 more points, it's got to be the equivalent. This is now 6 lines, so actually middle. So it looks like those 2 points are where the mirror line would be. Okay. So there's my mirror line. Now, we have done this. When we describe fully the single transformation, the first thing we've got to write is the fact we think it's a reflection. But I wanted to point out there are 2 marks here. Saying reflection is only going to get you 1 of them. Right. So we need to say where the mirror line is, and we can't say reflection in the mirror line. We have to say what the equation of the line is. So once we've drawn our line in, what is the equation of this line? Good. Y equals 1. So we could then say reflection in y equals 1. Now just to say, whatever you put here, in, about, what, it doesn't matter. Right? There's 1 mark for getting reflection, there's 1 mark for saying y equals 1. How you link those together does not matter. You could just write reflection y equals 1 if you like. Okay? Now I've got a question for you though. Might be harder to find, but let's talk rotation. Let's talk rotation. Be a good point to talk about it. Any ideas how Well, if we think it could be a rotation, okay, what we've got to find is what we call the center of rotation, right? Well, that's not what the center of rotation is, but yeah, we've got to think, is it 90 degrees, is it 180 degrees, what direction as well. But what we've got to find first is the center, which is the point at which I put my pencil and do the rotation. So I've given you some tracing paper. Okay, I've given you some tracing paper. Do you know how to use your tracing paper to find the center of rotation? Okay, so what I would suggest you do is put it up that way rather than that way. Doesn't matter, but I think that, you know, we've got to find a point. Make sure it's kind of at the top, because what you need to do is put your tracing paper over it, trace it, right, and then start putting your pencil on points of the grid on the tracing paper, and then rotating the tracing paper and see if you can match Q onto P afterwards. Okay. Now there, remember, you need to keep the initial Q on the Q. Okay. So see whether you can do it. It's a bit of a trial and error process at the moment. Okay, so what have you found? Could it be a rotation?
Yeah.
Why? What have you found? Why doesn't it match? What's the problem? Could you get it close? And what does it look like, though? What's the problem with it? Do you get it to match, but it looks like this? Is it kind of that way?
Yeah.
Yeah, but it's more
Think
properly, yeah. Like two sides.
So I think I got it, so it's there. I got it kind of close, but what I noticed straight away though was that actually it's the wrong way, isn't it?
Yeah.
Okay, it is the wrong way round. So that would suggest this is not going to be a rotation at all. But what you've done is you've been through the process. So if we have a look at the next question, we'll come back to the enlargement. It says, on this grid, rotate shape R 90 degrees clockwise with center 0, 1. Now, what I want to point out is you should always kind of look at this because it gives you information if you had to describe it. So do you notice it says rotate 90 degrees anti-clockwise, and it gives you a center. So there's 3 points there to consider. Okay, so how do we do it then? So we're going to mark center 0, 1. So 0, 1 will be here. Okay. Which way is clockwise? Okay. So we're going to go that way round. So what you do is you get your tracing paper, you put your pencil on 0, 1. Make sure you get that the right place, otherwise you're going to get the wrong thing.
Clockwise. It says anti-clockwise.
Okay, yeah. Good. So we're going to go anti-clockwise. Right. Now, I'll give you another tip. When you're going to do it, and it's got to be exactly 90 degrees, if you need to, on your tracing paper, draw a little bit of the line that's the axis, okay, on your tracing paper, just because you want that to match up with the line that's 90 degrees. So you're going to be looking for this part to match up. If you don't, so make sure you've done the full 90 degrees. Sometimes you think, oh, have I done it or not? I don't know, but that's my little tip, is to, using your tracing paper, put a little bit of the axis as well, make sure it's lined up nicely. Okay, so it should be clear it's a rotation. Remember we wrote notes and said it looks like it's pointing down now, you know. So I would say instead of facing to the side, it's now pointing up and down.
Well, it's still a little bit.
Are you doing it at the right point?
Now, obviously, you've got to be very careful that you definitely do the centre in the right place. Don't get your coordinates the wrong way round, for instance. Alright? Because if you do that, you're obviously going to get it wrong. But what will happen is, even if your centre is not in the right place, you'll still get one of the two marks if you did a rotation and you still did 90 degrees anti-clockwise. So it's not, you know, you don't lose everything. Alright? Okay, let's go back to the previous bit because we've had a look at rotation, but now it says, for the previous one, where we did our reflection, right? But the next question says about an enlargement, right? So if you can see, it says, on the grid above, enlarge shape P with a scale factor of 3, centre O. Right? So, again, enlarge, so you should be making note of this just in case you've got to describe. Enlarge with a scale factor of 3 and centre O. Now, do you know what those things mean? No. What does centre O mean?
Put a dot on zero.
Put your dot on the origin. So that is the centre of enlargement. Do you know what a scale factor of 3 means? Gets 3 times bigger. Okay? So there are a couple of ways to do it. So which one have we got to do? Shape P. So we've got to do P. Enlarge it 3 times. Okay. So how do we apply a factor of 3 to P? How do we do it? There's a couple of ways to do it. So I go through my way, the grid method first.
Just add 3 on to each side.
You could, but what's important is where it ends up. That's why we've got a centre. So we should really refer everything back to O to start with. So what I do is I take each point and I go, how do I get to each point? So what I do is this. I go, let's look at this point. I have to go down 2 to get to it from the point that it gave me. So I'm going to go back and I'm going to do that 3 times. So down 2, down another 2, down another 2. Okay? So do you see how it's 3 lots of what it was originally? So my new point is going to be there. So that's a nice, easy one. It's just straight down the line. Right? Change to do this. Now, I can do it another way as well. So, for instance, this point here, I will go across 3, down 1. So I've got to do that 3 times. Across 3, down 1, across 3, down 1, across 3, down 1. So that will be that point. That one's done. That one done, that one's done. So I've got point here, point here. Alright? You see how I've done that? There is another way we could do it as well though, which is we could actually, instead of like for this point here, right, I can do it the same thing. I can go across 1, down 1 and do that again. Across 1, down 1, across 1, down 1, which would be here. But I can also say, well, we'll go directly to it. and I can keep going 3 times that. So that through 1 square, let's do it again, let's do it again. So actually it's just there. Alright. Now normally, once you've got a few points already sorted, you can kind of figure out where the final point needs to be. And we do it by saying, well, if this line here was too long, how long is it going to be in the... So not only are the distances from the point tripled, but each length is also 3 times as long. So if that was 2, it's now going to be 3 lots of 2. 1, 2, 3. That would be my final point. Okay. So what we can say is the distances from O are multiplied by 3, but also lengths of the sides are also multiplied by 3. Okay. What I would like to point out at this stage is your shape should not be twisted at all. Okay, so this side here should be parallel to the new one, and this one should also be parallel to this one, and these two should be parallel as well. Okay, so if your shape is slightly wonky or you've done something wrong, okay, so just check. So Olivia, I think I can see one of yours is not quite right. Now this bit is it's an important thing actually to remember. If you've done a scale factor of 3, the lengths of all the sides are multiplied by 3. So it might be a problem solving question for you. Okay. So that's probably an important thing. Okay, question 5. We're on to ones where there's a lot of describing rather than doing. Now, what do you think? So, again, it says, describe fully the single transformation, and what do we notice? There are 2 marks, so we've got to write 2 things. So what do you think? What does it look like? It's just moved. So that would be a translation. So we can go with translation.
So you have to say it's translation.
Well, that's for 1 mark.
And then they have to be.
Yeah, so then it's like, how far? So how do you say it? Now we've got to get the right way. So it says maps triangle P onto Q. So that means we're going that direction. Got to get that right. Okay. So how do we do it? Any ideas? Okay. So what would you say?
One equals 3 and x equals 4. Okay. Where'd you get x and y from?
Well, what I would say is we've got to figure, I thought what you were saying is we've got to figure out how far we move in the x direction and the y direction. Okay? So do we go left or right?
Left.
So we're going to go, we can say left, how far?
1.
Well, no, you see, that's the common mistake. 2. Because what we should do is pick a point where we start and then find the same point in the image. It's called an image. Okay? So how far do we move? We actually have to move 2. So left 2 units. Okay? And then we have to go up 1 unit. Now, I think for you guys, for the foundation level, that's fine. That's all you need to say. But there is way, if you want to be really properly correct, we would actually change this 2 units left to 1 unit up to this, a column vector, where we would say we do the x direction and then the y direction. Okay? And we would say that if it's x is left, would be a negative x. If it's right, it would be a positive x. And with y, if it's down, it's a negative y. If it's up, it's a positive y. Okay, so in that way, what do you think the two numbers would be? Negative 2 and positive 1. So we could do it that way. Okay, rather than having to write left and up, you could just do column vector. Alright? Which would be a technically more correct way of writing it. But no problem if you just remember left and right. But don't forget, make sure you pick the right point. Because people would make a mistake and put 1 and 1. Yeah? Good. Any questions? Okay. Let's do this one now. I'll let you do it. So what do you think it is first? You've got to describe fully. Now, again, I will point out that. How many marks are there? So what do you think? How much have you got to write? 3 things. And actually, that gives me a clue straight away. But what do you think it looks like? Rotation. Okay? Go for rotation. How many degrees do you think? Well, if it was 180, it would actually just kind of be upside down. And it's not quite upside down. It actually, if you just forget about where it is, how would you go from that just to that? You just rotate it 90 degrees, wouldn't you? So it's actually a 90 degrees. How far? No, sorry, not how far. Yeah, which direction? Clockwise or anti-clockwise? I go clockwise. Okay, P on to Q. Okay, so there. Well spotted. So it is 90 degrees anti-clockwise. Now, just one thing here. If it was 90 degrees anti-clockwise, it could, obviously, we could go clockwise, but how far would it be? Not 180, no. Instead of going 90 degrees anti-clockwise, you could go the opposite direction, but how far would you have to go?
240?
Or what would it be? So if you're going to go round, if your starting point, if you're going to go 90 degrees in one way, okay, that's 90. If that's 90 degrees, oh, sorry,
60.
going in this direction 90 degrees. If I want to go the opposite direction, how far is that?
360 take away 90.
Yeah, 360, take away 90, 270. So it could be 270 degrees clockwise. You're also allowed to say that. Okay, either or. What's missing for the third mark? Where you put your dot. So centre, have to find the coordinates, and that's why I'm going to let you do that. So you found the centre here, yeah? So if you put your pencil here and rotate, it does end up. So what do we call it? Well, we could say 0, 0, or just O for origin.
That's what origin is.
Yeah.
Origin is
O for origin, the starting point of the axis.
Yeah, you can use that word like.
Now, what it does, I'm going to leave you to, on the grid, translate triangle Q, 4 squares to the right, 2 squares down. Go for it. Done it already? Go for it. Okay, so it says, so translate Q, so you start at Q, 4 squares to the right, so pick a point, I'm going to pick the top point this time. I'm going to go 4 squares to the right, so 1, 2, 3, 4. And then it says 2 squares down, so from that point we go 1, 2. Now I've got to remember that that is that point, therefore my triangle, if I redraw my triangle, will end up looking like that. It does say label it R, so better put an R in there.
Sometimes I mix up my left and my right.
Me
I
too.
do,
In
but I
ICT,
don't-
I always say that I never mix up my left and right because I just do this.
Yeah.
No, like if you ask me on the spot,
Right, again, we've got to describe fully, so we're now on question 7, describe fully the single transformation that goes P onto Q. Now, I think straight away we know, well, there are 3 marks again, so we've got to make sure we get them. And what is it? We know it's an enlargement. Okay. By the way, don't worry about spelling. Don't fuss over it at all. We've got enlargement. Now, that's 1 mark, so think it through. 1 mark. And even if that's all you can write, you can't remember what to do, at least write enlargement, alright, and get the 1 mark. What do we need? Go on.
when you do enlargements, you have to do the like over like the corner, the same corner is over however many and up however many. So you could just say it got bigger by a certain.
Well, yeah, we have to work out where we start from as well. But we can say factor what first? How much bigger is it first? As we figure that out.
For this, can you like find something to times P by to get Q?
Yep.
I don't know what it is.
So we just pick a side. So for instance, I would go, well, look at this side, and then look at the equivalent side on the bigger shape. How much bigger is it?
4.
3 times. It was 1, it's now 3. We could check the other one as well. So that's 2. What would we expect this one to be then? 6. So we've got 2, 4, 6. So it is. So we've checked. We don't need to check that one, but it would pretty much be the same. Okay. We know it's a proper enlargement because they did it. So we've got a factor 3. So times 3. And actually, if you can't remember the word factor, just put times 3. It's fine. And now we need to find the centre. Where does it happen from? And there's a nice, easy way to do this if you've got your ruler. Okay? So what you do is this. You take your ruler, you match up the points. So for instance, we go from top point here, go to the top point, and then keep going. But make sure you definitely are accurate and you draw. So you'll notice how it goes through all the squares, all the way down. So just be accurate. Check that your line doesn't deviate away at some point. Okay? Yeah, you'll need a ruler to do this.
I have one.
Alright. We still are none the wiser where the centre is. We know it's going to be on that line somewhere though. So all we need to do is pick another point. So I'm going to go from this point here and do the same thing. Okay? And if I'm accurate again, now the 2 lines cross somewhere.
Okay, so that has to cut
And I could check by doing the 3rd point. So this point here goes through. And again, if I'm careful, they are all meeting at this point here. And it will be on a grid point. It won't be in the middle somewhere. Okay. So the centre, I think, is where? What coordinates? So it's 4, 3. So I think centre 4, 3. Now just to show you something, so we've done the straight line approach, but if I actually wanted to, I could do this later. So cross 3, up 1, And if I do a cross 3, up 1, cross 3, up 1, so we do it 3 times, just like we did before. Same thing approach. But it's harder to figure out that point, so we do the point using the straight line. Make sense?
Yeah.
So, could you now have a look at question 9? That's the last one I want to do with you. And then you've got others you can finish up. The reason why I want to do question 9 is because it's a hard... I'm going to do part B. Reflect shape Q in the line y equals x. Reflect Q. So, you'll notice though this time that the mirror line is diagonal, and this really messes people up. So again, you've got your mirror. Use it. See where it ends up, because it might surprise you where it ends up. Okay?
I can't find it.
Now I would say another way to do it is this. Do you remember we did before? Point to the line and go the same the other side. Again, we've got to go directly to the point. Alright? And you might be surprised where it ends up. So for instance, between those two, I know I've got that line there.
Oh yeah. It's like
Right.
sun shining on
This
something.
point here, right? There we are. This point again, remember we've got to go at 90 degrees, so we go 2, 3.5 squares. So we do half, 1, 2, 3. So that point goes there. So we always go at 90 degrees to the mirror line. So that's this line, that joins these two. So it's going to be like that. And then this point, we can now have an educated guess that it's going to look like that. So this might be a tricky one for you to get your head around. Okay?